In today's video, we're going to discuss visualizing our geographical data, considering both the longitude, the latitude, the median house value, as well as the population size. In the last lesson, we discussed how to create a test set, and in today's lesson, we're going to be taking our training set, which is the complement of our test set, in order to visualize these particular characteristics. Before we get into today's video, make sure you hit the subscribe button down below and like the video for more content just like this. In today's video, let's discuss how exactly we can visualize our geographical data. In particular, we're going to be using a scatter plot. So when we're talking about using a scatter plot, what we first have to understand is where we're getting our data from. We're going to be getting our data from our test set that we created in the last lesson. Now, if you remember, our test set was stratified information. We used the stratified shuffle split class in order to create a stratified sample of the data that was emblematic of the different strata that each of our training sets were divided into. And if you remember, we talked about how we could take the median income for each of those districts and divide it into strata from 15,000 to 30,000, from 30,000 to 45,000, from 45,000 to 60,000, and so on and so forth. And we were able to use the stratified shuffle split class in order to divide our data into those particular characteristics. And then from that, we were able to use that particular column in our housing data frame object in order to create our test set and our training set with an equal proportion from each of those particular characteristics. And so when we run this particular function, we're able to see that roughly 35% of our data comes from people who have a label of 3, which is about 20,000 all the way to about 50,000, or some number, I believe. Yeah, so 3 would correspond to 30,000 to 45,000. And then you had a label of 2 for 31% of the data, and then 17% of the data, and so on and so forth. Now, what we're going to do today is we're going to take the test set, the training test set, in order to visualize our data. Because remember, we're going to use our test set at the very end, once we have our model, in order to test whether or not our model is correct or incorrect, using unlabeled instances of the data, and then comparing them to what the model should have outputted. So let's go ahead and take a look at this. So what we're going to go ahead and do first of all is we are going to rename the housing object with the test set, with the training set, and we're going to use the copy function in order to copy that. And so let's go ahead and print out the housing there, just that way we can see that again. And when we print that out, we see that this is the same data that we have, except this is going to be our training set. But remember, our training set should be emblematic of what our actual entire data would be, what our entire housing data set was. It should be emblematic of that in terms of what proportion of it is coming from different sectors in terms of the housing median income. So that's our housing data. Now let's go ahead and use the plot function, and we're going to create a scatter plot with a x value of longitude, a y value of latitude. So we're going to have our x value will be our longitude, and our y value will be our latitude. And then we'll have an alpha property. What the alpha property will basically allow us to do is this parameter in the function is it will basically say how transparent each of our dots are. Now, if you have alpha set at 0, that means that it's fully transparent, meaning that it's going to be invisible essentially, right? We don't want that. On the other hand, if you have 1, which is the other end of the spectrum, if alpha is set equal to 1, that means that it's going to be opaque essentially. Okay, so it's basically like a cardboard box essentially, right? So let's go ahead and run this. And when we run this, we see here that we have particular areas that are darker in color. Those particular areas that are darker in color represent the fact that there are more districts in those areas, more districts in those particular areas. So you see here that at these particular latitudes, at a latitude of 34, you see that you have more people. At a latitude of 38, you have more people. At a latitude of 38, intersecting with a longitude of 122, you have especially a lot more people. Latitude of 34 intersecting with longitude of negative 118, you have more people. And you see where exactly there is a more districts in each of those areas. So there's basically more districts in those areas. All right, so that's what this function did. And we can see how when we visualize our data, let me just go ahead and run that again. We see when we visualize our data, which areas have more districts in them. And again, those might be more urban areas. And so that's how what we were able to do there, comparing the longitude to the latitude. And this is more of understanding our data. We're not going to be feeding any of this data to our model. This is more of just us being able to understand what our data looks like. The next thing that we want to do is we want to visualize the population and the median house value. And we're going to have the code here below at the bottom. And you see that this code, this plot function takes in several parameters. So you see here that you have what type of graphing system are we using? Well, we're using a scatter plot. Our x value is going to be longitude, and our y value will be latitude. We already covered that before. Our alpha property is going to be 0.4, so roughly in between being opaque and being transparent. Our s value represents how big. Let me go ahead and go through these one by one here for you because I wrote these down ahead of time. Our s value will represent the size of each dot based on the population size. So that's important there, okay? So it's going to represent how big each of the dots are based on what the population size is. So we're going to take our housing population and we're going to divide it by 100. The reason why is because if we just took our housing population, going back here to our, let's go back over here. So going back to our housing population, we see here housing population. You see that these are very big numbers. 558, 565. If we simply just said housing population and we didn't divide it by 100, what that would result in is that would result in our dots being way too big. And so we're going to divide them by 100, and that'll bring the population, the size of each dot to be much smaller. The max value will probably be like something like 20 or something like that. Or not 20, but it'll be something like something like 7 or 20 or something like that. So it's going to be a very smaller number. And so we want each dot to be smaller. And so how is this helpful for us? Well, it's going to tell us that if we have a smaller dot, then we have a smaller population size for that district. If you have a larger dot, then you have a larger population size. Now the label is going to be population, so we're going to set the label equal to population. And again, all of these are the parameters that we have below. The fixed size simply is setting the width and the height of the histogram. So we're saying 10 is the width, and sorry about that. Let me go ahead and go back to that. So we're basically saying that x is the 10 and y is the 7. So it's going to have an x value, a width of 10, and a y value 7, height of 7. C is equal to housing median value. So what this does is basically, this is regarding the house value. So how expensive each of the houses are. So let's go to median house value here. Median house value. And this is just a test file that I created, by the way, just a test file in order for us to run some basic stuff. You see the median house values here are like 452,600, 77,100. Each of these are the median house values. And what we're going to do with that is we're going to get all the median house values, and we're going to use a CMAP in order to assign a color for each of them. Let's go back here to the bottom. We see here that we have here a housing median value. So that would correspond to each of the values here, okay, housing median value. What we're going to go ahead and do is we're going to use the CMAP, get CMAP, and we're going to use the jet here. And what this jet is going to do is basically it's going to assign a color gradient for each of those dots from blue all the way to red. And so basically it's going to say if a particular value here is lower in general than all the other housing values, we're going to assign it with a color of blue. If it is higher relative to all the other housing values, we're going to assign it with a color of red. So that's basically what this CMAP does. It basically assigns a color gradient based on whether the house value is low when you compare it to all the other house prices, or if the house value is high. And I believe it's something like there's an equation where they consider the max value of the house and compare it to the min value of the house, and then put that value of that particular instance and in order to compare it, in order to assign a blue or a red or an orange or a yellow. And so if a dot were to be green, for instance, we would know that that house would have a median house value. That would be in the middle of all the house values. If it were to have a value of red, that would be a very expensive house, and we'd be able to visualize that there. And then we have for our last one, color bar equals true. Basically, this is kind of like a legend in order for us to understand what each of the colors mean. And so that's what it is. All right, let's go ahead and run this, and let's see what the output is. All right, so let's take some time to create it, and let's take a look at this. So let me go ahead and I think I can zoom out a little bit. Can I? All right. Okay, good. So you see this here. So you see some of the data here, and we're able to visualize the data. Notice here that if it's that's a 500,000. So 500,000 is the max, more expensive house prices. And then here you have all the way down to 0, right? And so you see here that there are some areas where the colors of the dots are red in many of those dots there. And that would represent an area where the house population, or not the house population, but um, the house price may be higher. The median house price for that district might be higher. You see a lot of green areas, kind of, and yellow areas. Those are house prices that are kind of like in the middle, right? So they're not too expensive, too cheap. But you see a lot of areas where house prices are relatively cheap overall, like in the 100,000 range. Those are in the lower ends of the spectrum. And you can kind of understand remember, this is California. And you see here that these areas over here are probably more closer to the ocean, right? Whereas these areas over here, the blue dots, in general, that might be area that's more like, I'm not sure California, but more like wooded area, not necessarily urban areas. And so you see that places that are more closer to the Pacific Ocean are going to be more expensive. Okay, so that's something that we can observe from that data. What else should we be able to observe? Well, obviously the population. Remember that a bigger population, going back up to the notes here, it's basically a smaller population corresponds to smaller dots, and a larger population corresponds to larger dots. So you see here, some of the areas here have larger dots, and the areas that have larger dots would have a higher population. Now, it is still a little bit difficult to understand, difficult to see, but you can see some areas, like for example, you see the red dot right over here. Let me go ahead and zoom in a little bit here. The red dot right over here, that might be a district with a very small population, whereas some of the districts here, this district in particular maybe, might have a bigger population. And so you can see how the population density is represented by the size of the dot. All right, and so that was a little bit going into our data. Now we understand a little bit of our data. We understand where where there's more districts, comparing the longitude to the latitude, where exactly those more districts occur. We also see where there's a higher population, where the house prices are higher, and that type of information. And so we basically went through our data, was able to visualize our data using those particular functions. Now, if you like this video, make sure you hit the subscribe button down below and like the video.